This video is going to be the second part of stock evaluation, and it's going to cover the dividend discount model. So this dividend discount model says today's stock price should be equal to the present value of all expected future dividends. So suppose we know the future dividend is going to be D1, D2, D3 in the future, and suppose in the time t, the price for stock is going to be PT. So we can discount this future cash flow back to today's value. Okay, so the dividend 1 discounted by 1 year, so divided by 1 plus R. Dividend in year 2 divided by 1 plus R squared. Okay, and in the end of the holding period, time t, the dividend in time t plus PT, the price at time t divided by 1 plus R to the t. And adding all those cash flow together, we get the today's present value. Okay? And if we assume we are going to just hold this stock forever, we are not going to sell it at any point, and we are going to receive dividends forever. So that will also give us the P0. Okay? So there are different ways we can forecast the dividends. So there is usually a pattern that the company will distribute its dividends, and we can use the past records, the past recording of its dividend distribution, and to make a forecast for the future. Okay, so this is just a general model, and let's look into the examples. So suppose the current forecasts say that for XYZ company, they are going to pay dividends of 3.24, and 3.5 over the next 3 years. And at the end of year 3, and you are anticipated to sell the stock at a market price of 94.48. So what's the current price of the stock? If we know the expected return is 12%. So we just discount this cash flow. So in year 1, going to receive $3, discounted by 1 year, divided by 1 plus 12%. In year 2, we are going to receive $3.24, discounted by 2 years, so 1 plus 12% squared. In year 3, we are going to get the third dividend, $3.5, as well as selling it to get capital gain or whatever the price is to get a total of $94.48 and discount this by 3 years, so divided by 1 plus 12% to the third. And adding this discount cash flow together, we get the present value of $75. Okay? So if you forecast to receive this future cash flow, you discount it back, it should be the fair value of the market price today. Okay. So next, if we forecast only dividends, we are not planning to sell yet. We are going to hold out the stock indefinitely. And if we forecast there are going to be no growth, so in other words, no growth means the dividend will be a constant number, then we are going to receive constant dividends forever. And then the value of the stock is going to be a perpetuity. We are going to receive same dividend, they call it DIV. We are going to receive it in every time period, and it goes forever, and that's exactly what a perpetuity is. So here, the price today, using the formula for the perpetuity, get the DIV divided by R will give you the price today, P0. Okay, and by having no growth, like getting a constant dividends, we are also assume that the earnings are all paid to shareholders. Okay, so we assume the company is not to retain any earnings. All the earnings are paid to shareholders as dividends. So the dividend here is also equal to the earnings per share. Okay, this is the assumption we make, and the P0, the present value, can also be written as the EPS, the earnings per share divided by discount rate. Okay, so this formula is true, is holding only based on the assumptions that there's no future growth. We hold the stock forever. The dividend equals to the earnings all the time. Okay, and it's distributed. Earnings are distributed to the shareholders. There's no retained earnings here. Okay. So next, there is going to be some adjustment to this model, saying what if the dividend is going to grow. So this is called the constant growth dividend discount model. Okay. So the model says the dividend is going to grow at a constant rate, G. Okay. So in year 1, we are going to receive dividend 1. Next year, in the every year after, the dividend is going to be received is going to be 1 plus G times the dividend in the previous year. Okay. If you write down and discount this cash flow, you will see it's still a geometric series. And apply the formula for geometric series, you will get P0 equals the first year dividend, DIV1, divided by R minus G. Okay. So R here is the discount rate, and G is the growth rate. And we will talk more about this G a little bit later. Okay. So let's look into an example first. So what's the value of the stock that expects to pay a 0.74 dividend next year, and then increase the dividend at a rate of 5% every year, and assume the expected return, or the R, the interest rate, is 7.8%. So apply the earlier formula, P0 here. The dividend is 0.74 in the first year, in next year, in year 1. So DIV1 equals 0.74. Interest rate, the discount rate is R, which is 7.8%. And the G, the growth rate, is 5%. Okay, so it's 0.74 divided by 0.078 minus 0.75. Okay, so the present value today, this stock, is 26.43. Okay. Next, let's talk about G here. So what's this G is exactly? Say the company, when the company has earnings, okay, they can make a decision. The first is to retain this earning and use this revenue for future investment. Okay, so they can expand their production line, they can do other investment, or they can distribute this free cash to the investors. Okay, so you distribute them as the dividends. Okay, so if the company decides to retain this earning and to reinvest the free money, the cash they have, so in the future they may have more factories, they may have more production lines, so they are going to earn a higher revenue in the future. So in the future they will have more net income, and they will have higher dividends possible in the future. Okay, so we call the fraction of earnings paid out as dividends as the payout ratio. Okay, and we call the fraction of earnings retained by the firm as the clawback ratio. Okay, so the amount you decided to pay out is the payout ratio, and the amount the company decides to retain and to do the future investment is the clawback ratio. And the sustainable growth rate is the firm's growth rate that, if it plots back a constant fraction of earnings, maintains a constant return on equity, and keep its debt ratio constant. Okay, and this sustainable growth rate is the G we saw earlier. Okay, so the G here, the definition for this G is saying the firm's growth rate, if it pulls back a constant fraction of earnings, maintain constant return on equity, and keeps the debt ratio constant. Okay, so this G has actually two parts. So the first is the proportion of the earnings the company decides to reinvest, and the second part is the profits generated by the new investment. Okay, so this G tells you how rapid the company grows. And there is a formula for G actually. So the growth can be derived from applying the return on equity to the percentage of earnings plowed back into operations. So the first is the return on equity. What's the rate of return, the profits you can generate from the new investment? And the second is how much you plow back, okay? The proportion of the earnings you decide to reinvest. And multiplied by the return on equity, multiplied by the plowback ratio gives you the sustainable growth rate, G here, okay? And when we evaluate a potential project, a potential investment opportunity, we can calculate the present value of the growth opportunity, or we call it the PVGO. So it's the net value, the net present value of a firm's future investment. So it's making a comparison here. What if we retain all our earnings? Okay, sorry. What if we distribute all our earnings? We don't do the investment. What's the present value is going to be? And what if we decide to do the investment and retain parts of the earnings? What's the present value is going to be? And the difference in those two values is the net present value of the company's future investment. It's this PVGO here. Okay, it's going to make more sense if we look into one example. So here the example, the Aqua America has an ROE of 12.5%. and a book value per share is 9.86. It intends to plow back 40% of its earnings, and the opportunity cost of capital is 7.8%. So what's the stock price? So we know the earnings per share is 9.86, the book value multiplied by the return of equity and multiplied by 0.125. So earnings per share here is $1.233. Okay. And the formula for the growth rate, G, is the ROE multiplied by the plowback ratio. Okay, so it's 40% multiplied by the 12.5%, the ROE. So the growth rate is 5%. And the dividends, okay, so you have earnings per share, and you know you are going to plow back 40%. So the amount you are going to distribute to the investors is 1 minus 40% equals 60%. So the dividends is 1.233 times 60%. So the dividends in year one will be $0.74. Okay. So to calculate the present value, it's going to be P0 equals dividend in year 1.07 divided by the opportunity cost of capital, or discount rate, interest rate here, the 7.8% minus the 5%. Okay, so this is the formula we saw earlier to calculate the present value in this dividend discount model. And that gives the present value is 26.43. So this is the value if the company invest in this project. This is what the present value is going to be. Next, what if this company decides not to invest? Okay, so if the company decides not to invest, still the earnings per share is 1.233 as before. And because there is no investment, so the growth is zero. Okay, there is no reinvestment. All the money goes to the shareholders. It is the dividends. So the dividends is equal to the EPS, equals to the 1.233, and the discount rate is R, which is 7.8%, and there is no growth rate. The growth rate is zero. So the P0 here is just 1.233 divided by the 7.8%. So the present value of the stock price today should be 15.81. Okay, and the PVGO is just the difference between those two. So what we get if we invest, the present value 26.43. What we get if we don't invest, the P0 is going to be 15.81. The difference is 10.62. So in other words, if we decide to invest in this project, the present value of this project will increase the stock price by 10.62, and that's the PVGO here. Okay. Let's look into another example. If the company forecasts to pay a $5 dividend next year, which represents 100% of its earnings, and this will provide investors with a 12% expected return. Or the company decides to plow back 40% of its earnings, and the return on the equity ROE here is 20%. So what's the value of the stock before and after this plowback decision? Okay, so if there is no plowback, all the money goes to the investors as dividends, and there is no growth on dividends. So P0 is the total earnings per share, $5, divided by the discount rate, and R here, 12%. So the percent value will be $41.67. And if we decide to plow back, so the plowback ratio is 40%. So 40% times the ROE, the return on equity, is 20%. 0.4 times 0.2 gives the growth rate of 8%. Okay, and the price here is the new dividends because we are plowing back 40%. So the dividends will only be 60% of your old dividends. So the earnings is $5. You decide to retain 40% or $2. You only have $3 as dividends you can pay out to the investors. So now the dividends become 3, or 5 times 1 minus 4%, 40%, or 5 times 60%, that's $3, divided by the R minus G. R is the interest rate or discount rate, 12% here, and the growth rate is 8%. So 12% minus 8%. That gives P0 as $75. Okay, in other words, if you decide to invest in this project, the present value increase to $75. Okay, and the difference between those two is 75 minus the 41.67, or 33.33. Okay, so that's the present value of the growth opportunity. Okay, so I hope those two examples help you to understand the concept of this present value of growth opportunities. So next and last, so what if the growth of the dividend is not constant? Say in year 1, we are going to receive a dividend of DIV1, and in year 2, we are going to receive dividend as DIV2. And in year H, we are going to receive a dividend of DIVH. Okay, and there's no obvious relationship between those dividends. Okay, and if we can forecast the price at year H, we call it PH. So we can still using the same discounting method to calculate the present value of this stock. Okay, that is, if we can forecast the future dividends, we can always discount it back to get the present value. Okay, even if the dividend is not constant. So there's not going to be a nice formula here, but we can still using the traditional old way of discounting the cash flow. So let's look into example here. So the earnings and dividends are given in this graph, in this chart. The discount rate is 8.5%, and the perpetuity growth rate of 5% begins in year 6. And what's the present value of the stock? Okay, so there are two parts. In the first 5 years, the dividends is not going to be a constant value. There are going to be no like obvious relationship. And starting in year 6, it's going to be a perpetuity growth of the dividends of 5%. So we can apply the earlier formula. Okay. So first, we calculate the present value of the first 5 years dividends. So based on this graph, we say the earnings is 4.75 in year 1, 5.23 in year 3, in year 2, 5.75 in year 3, 6.32 in year 4, and 6.95 in year 5. Okay, and the dividends is 60% of earnings, or in other words, they are plowed back 40% of their earnings. So the dividends is 60%, so you just use the 60% times the earnings, you can get this dividends number or it's already calculated or given in this question. So that's going to be the 5 dividends you are going to receive in the first 5 years. You just discount them back to get present value. So for year 1, it's the 2.85 discounted by 1 year. Discount, so it's divided by 1 plus 0.085. Okay. And in year 2, it's 3.14 divided by 1 plus the 8.5% to square. Okay. You'll do this for the first 5 years, you can get a present value of 13.5. That means the 5 dividends in the first 5 years will have a present value of 13.5. Starting in year 6, it's going to be a nice constant or perpetual growth rate of 5%. Okay, so in year 5, we are going to receive a $4.16 of the dividend. So the dividend you receive in year 6 should be 4.17 times 1 plus 5% or times 1.05. So that's the dividend you're going to receive in year 6. And to calculate the present value of all the dividends after year 5, you can use the formula, which is the dividend in year 6 divided by the discount rate R minus the growth rate G. Okay, so here in this example, it's going to be the dividend in year 5 is the dividend in year 6 here is 4.38, as I said before, divided by R 8.5% minus 5%. Okay, so this is all the cash flow, all the discounted value you are going to receive after year 6, and it's called PV5 because it's discounted back to year 5. Okay, you're standing in year 5, you look to the future. This is the value you are going to receive in year 5. This is the value that's equivalent as the present value in year 5 for all the dividends you are going to receive starting in year 6 and afterwards. Okay, that's equivalent to $125.14. Okay, however, we want to calculate the value for today, which means we need to further discount this value back to today. So it's $125.14 divided by the discount factor 1 plus 85% to 5th. Okay, discounted by 5 years. And you're adding back the first 5 years dividends, and you will get the P0, today's present value of 96.72. Okay, so let me recap this question. So there are 2 parts. The first is the non-constant growth of the dividends. You'll use the traditional way to discount cash flow. Starting in year 6, it's going to be a nice growth model. So you apply the growth model to discount to get the present value in year 5. Okay, remember here you are starting in year 5. The first dividend DIVI here, DIV1 here should be DIV6. Okay, so that's the first year you receive dividend in this part of the model. Okay, so that's why we use 4.17 multiplied by 1.05. And then you calculate the PV5. The present value in year 5 is this number. You need to further discount it back to today. Okay, and this is how you discount it back today, divided by 1.085 to the 5th, adding back to today's value of the first 5 dividends, and you get the total today's value of the stock, which is 96.72. Okay, so this is kind of like the hardest question I will go for stock valuation in the exam. Okay, but you need to make sure you understand this example. Okay, so there's a chance you're going to see it in the final or in the next midterm. Okay, so that's it.